This is Engage New York, Module 2, Lesson 26. This is Concept Development. Now, I want you to look at these two problems. I started them off for you, and if you notice, this is 904 divided by 32. This is 456 divided by 16. Now, if we look at the division process, we notice that this ends up with 28 remainder 8, and this quotient is 28 remainder 8. But are these two numbers actually equivalent? Are they actually the same? Are these the same? Not exactly, right? So we're going to take this and we are going to take it and work with it so that we can show that these problems really are different. So we're going to pull this number out so that we don't end with a remainder. So that's our big idea for today. We're going to make sure we do not end with a remainder. All right, so Bradley was brilliant and he had an insight and he said, well, I'm pretty sure that these quotients are the same because 16 is half of 32. And then he said, I am assuming that 456 is half of 904. Like, wow, that was insightful. So now let's take it and let's start playing with this problem so that we can get rid of the remainder, okay? And we zero it out and prove, and let's just see what we end up with. All right. So we're going to have an estimate part and a solution part. So we're going to right here, estimate, solution. Okay? So now let's go 32. So we're going to put 32 divide 904 right here. And then over here, we are going to do some estimating. So, but we're going to go back to what we know about tens, ones, tenths, and hundredths, just like we just did in our problem set. In our fluency practice. Okay. So here we go. So 90 tens is what we're working with right now. We can't work with just 9, right? We're going to actually be working with 90 tens, correct? And then we're going to divide by 30 tens. All right. So 90 tens divided by 30 tens is going to give us 3 tens, right? So let's go ahead. Is 30 tens going to go, is my 3 going to be too much for up here? Is it going to be too much?
No.
You don't think so?
Yes, it will.
Yes, it will, because it'll be, if I do it times 3, it's going to end up being bigger than 90, right? So if it's going to be bigger than 90, we have to back it down 1 digit, right? So let's go 2. So 2 times 32, 2 times 32, 2 times 2 is 4, 2 times 3 is 6. Now we're going to subtract. And 6 minus 4 is 6. And 8 minus 6 is 2. And now we're going to bring down the 4. Okay? Now, let's do a little estimating over here. So 200, let's go 240 ones divide by 30 is going to give us 8 ones. So I wonder if how 8 will do here. Let's try, what's 8 times 32? So let's go 8. 8 times 2 is 16. Carry the 1. 8 times 3 is 24 plus 1 is 25. Oh, okay. So let's subtract. 14 minus 6 is 8. And we end up with 8. Well, our big idea for today is to not end with a remainder. So what we have to do is we're going to add a decimal and we're going to add a 0. Because we're going to be pulling this out. Now we're going to bring down our 0. Now 32 will go into 80 times. How many times? Show me with your fingers. 32 into 80? Yes, you're right. 2 times. So 2 times 2 is 4. 2 times 3 is 6. 16. Okay, I still have a remainder. Let's do this again. Let's see if we can zero this out. So 32 goes into 60. 32 into 60. 160. What do you guys think? Only one time? 32 into 160? So 32 and 32, 32, 32, 32. How many times do you think it'll go in? Cooper's calling 5. Oliver's calling 4. 5. You're calling 5. Zoe, I can't tell. 5. Okay, Bradley's calling 5. 5. Okay, let's try 5 and let's see what we end up with. Here's 5 times 2 is 10, right? Carry the 1. 5 times 3 is 15, plus 1 more is 16. All right, so our answer is 28.25. All right? Yes? All right, let's try 16 into 456. Well, do you know what? Instead of rewriting it, why don't I just take this off? Why don't we add a decimal point and add a 0? But don't forget, if you add that decimal point, you have to move that decimal point up as well, okay? Now we're going to bring down the 0 because we want to just zero this out. We don't want anything hanging. We don't want any remainders hanging around, okay? So now how many times will 16 go into 80? Well, 16 is almost like 20. 20 will go into 80 about how many times? Okay, so let's try 4. 4 times 6 is 24. 4 times 1 is 4. 5, 6, right? 64. Okay, so let's see what we get. 16. Oh, it's exactly. So that means there's one more group of 16 sitting in there. This means there's still a group of 16. So let's change that to 5. Let's cross that off and let's try 5. Okay? So let's go 5 times 6 is 30. 5 times 1 is 5. 6, 7, 8. Oh, look at that. It just zeroed itself out, didn't it? So now when you look at this problem, this is 28.5. There are the differences. All right. Yes? Okay, so let's take this on. So we're going to use standard algorithm. You're going to estimate and check. The check, of course, is going back. Now, that's an issue for a few of you, so going back and checking your answers. So that's something that we want to practice with, okay? So now we don't have that remainder. Remember how you would just add the remainder? Like you would multiply this number times this number? So let's try it. Let's see what's happening here. So, but this number is no longer 28. It's 28.5, right? times 16. Try it. Let's see what we get. Okay. All right. So once I multiplied 28.5 times 16, I went through the process and I knew I have one number behind the decimal and I had to go back and put that number back in the decimal. In the number, right? Because when you multiply, you kind of take it out and pretend it's not there. Multiply, and then however many times you had to take it out, you have to go back and put that in, right? All right, let's move on. So 26 divide 834 times 6. Now, if I were you, which I'm not, but I always just go up and add my decimal right away so I don't forget about it. So now I go 80 and 26. So 80 and 20. So I'm using my estimation skills, right? I'm going 80 and 20. So 80, how many times would 20 go into 83? How many times will 20 go into 80? 4 times. But this is 26. So it might be too much. So let's back it down one, okay? All right, so let's go 3. So 3 times 6 is 18. 3 times 2 is 6 plus 1 is 7. 13 minus 8 is 5. Okay, we're good. Bring down the 4. Bring down a copy of the 4, if you will. Now, how many times? Okay, so we have 50 and 20. Or you have 50 and 25. 50 and 25. Do you guys want to try 2? Okay, let's try 2, but I'm going to write it really lightly in case I need to back down my number, okay? So 2 times 6 is 12. 2 times 2 is 4 plus 1 is 5. Okay, I think we're all right. I'm going to bring down my 6, 26. Oh, look at that. It's going to zero itself out quite nicely for us. So our check, so I was doing my estimating. I was doing it mentally, right? I was thinking through my numbers. It's a good idea to write them down so you can see what you've already been playing with, because sometimes those numbers come back again. You can go, oh, I already know what that number is. And then our check is 32.1 times 26, right? Now, we're going to take that out one time and just pretend it's not there. We're going to do the multiplication, and when we come back, we're going to put that decimal right back in, correct? So why don't you try it? Show me you can do it. Show me. I do, we do, you do. There you go. All right, so now let's look at our problem set so that you have a clear understanding of the expectation. So 156 divided by 24 and 102 divided by 15 both have the same quotient of 6 with a remainder of 12. Okay, so this is going back to our initial problem. This is exactly. Now, are the division expressions equivalent to each other? So you need to answer either yes or no. All right, so you have to then use your knowledge of decimal division to justify your answer. So you're going to need to do each problem, and you are going to need to write, yes, they are equivalent. No, they are not equivalent. Construct your own division problem with 2-digit divisor that has a quotient of 6 and a remainder of 12. So this is my key. This is my clue to you about how to start this problem. If the remainder is 12, that means the divisor on the outside. So if you have a remainder down here, that means this divisor has to be bigger than 12, right? Doesn't that make sense? Okay, so knowing that, start playing with a number that's bigger than 12. Start at 13, then go to 14. So what you're trying to end up with here is a dividend in here. Construct your own division problem with a 2-digit divisor. So you're going to have to come up with a 2-digit divisor. Well, we know that divisor has to be bigger than 12. Okay, step 1. Step 2, the quotient has to be 6 and a remainder of 12. So what you're going to do, you know that you're going to have a number times 6 plus 12. So you need to come up with a number that is this number times 6 plus 12. Are you paying attention?
Yes.
This number, you know, has to be bigger than 12. Pick an easy number. Pick 13. 15. You need to multiply it and then add. So you need to take your question number, multiply it by 6, and then add 12 to get a number that goes inside here. This problem is on the test. Know how to do this problem. All right, then divide, then check your work with multiplication. So 13 divided by 36.14, then come over here and go quotient times 13, right? 2. Now problem 3. The weight of 72 identical marbles is 183.6 grams. What is the weight of each marble? So what are you going to divide? They're all identical, and that's how much they all weigh all together. So explain how you know the decimal point of your quotient is placed reasonably. Well, I know the decimal point is placed correctly because, and you need to finish that. You need to solve it. So solve. And tell me, how do you know you did it right? How do you know? I know this because I did this. I follow these steps, right? All right. Cameron wants to measure the length of his classroom using his foot as a length unit. His teacher tells him that the length of the classroom is 23 meters. How many centimeters are in 1 meter?
100.
Thank you. All right. Cameron steps across the classroom heel toe, and finds that it takes him 92 steps. How long is Cameron's foot in meters? What operation are we kind of using right now? What operation are we using right now? Yeah. So what operation do you think you might use?
Division.
I think that's a great idea. Okay. A blue rope is 3 times as long as a red rope. So blue is 3 times red, right? A green rope is 5 times as long as the blue. So green. So do you notice when I'm solving these problems, I'm writing out what I know. Okay? If the total length of the rope, if the total length of the 3 ropes is 508 meters, what is the length of the blue rope? So the blue rope is the one that we don't know. So this is going to be at least a 2-step problem. There's going to be a little multiplication, a little division, maybe a little subtraction. So that's for you to work out. Draw a picture. That is the best way to solve these problems. Draw a picture to figure out what you're solving for, and then work your way backward. All right, that is it. Come on back and check the problem set debrief to check your work before you start the homework.